I'm Carolin Frueh. I'm the Harold de Groff Associate Professor at the School of Aeronautics and Astronautics at Purdue University. Space debris are the human-made objects which are in space. You might think those are only a few, but there's actually a large number around the Earth, and now even pushing further out all the way to the moon. Once you launch the objects, even when the satellite is long dead or the rocket upper stage has fulfilled its mission, it stays in orbit. It does not automatically come down. Up to an altitude of about 1,000 kilometers, there's drag, meaning they lose energy, they might come down very, very slowly. However, anything further out, where our GPS satellites are, where our TV satellites are, there's no mechanism bringing them down. They can stay there forever. So we have basically three lines. We have the observations, we have the astrodynamics, and the characterization. One thing we have added to the research is no longer only looking in the near-Earth space, but also looking at the cislunar space, which is further out. With all the new and exciting missions like Artemis, we are having more traffic into the lunar region around the moon, but also all the space between the Earth and the moon. While that is cool and exciting, it does create the problem that we have space debris in that region as well. So for one, we have the Purdue Optical Ground Station, where we actually take observations of the objects in near-Earth space and cislunar. That includes the active satellites, but also the space debris. We can do mission support, for example, in that realm. And then we are looking for the astrodynamics. One is, how do we keep the spacecraft safe? What is the probability of collision? How can we compute that efficiently? How can we aid in go, no-go decisions when a collision comes up, when there are fragmentation events like an explosion, where do the pieces even go? While in the near-Earth space, we have a better idea. In cislunar space, they can actually go to the moon, they can come all the way back to the Earth, or just keep hanging out. On the characterization, we want to see what can we learn about the objects beyond their center of mass. They're very far away, we are not getting a resolved picture of them, but how can we still know like in which motion they are, what shape they have? That's important when you launch a mission and you lose contact. Are we still oriented, that the solar panels still get energy? Are we in free tumbling motion? That's usually a bad sign. How can we recover from that? When do we have the antenna point in the direction that we can try to make contact or reboot? It's also relevant for active removal of space debris. If people are planning a mission to remove space debris, go and grab it, more or less. The better you know what pieces you're dealing with, what's the shape, how much rotation do they have, the better you can execute those missions. We have a number of challenges. One is large constellations. We have a larger number of active spacecraft in space at the moment than ever before. This means they are flying relatively dense to each other. So we want to be aware, avoiding collisions, but also be aware that we're not littering and leaving the space debris behind, and how to manage the different interests that are in that space. The other big challenge is the cislunar missions, the missions that are going to the moon or to the L2 Lagrange points like the Artemis mission. This creating traffic in an area of space which is not used to have a lot of missions going there. And then how to balance them, how to make them not run into each other, how to avoid having explosions in that space and having all the pieces flying around to the moon, back to the Earth, and everywhere in between. These are some of the challenges which are on the technical level, but also on the legal level. We are working mostly on the technical level to have solutions ready in order to tackle those problems. Working on space debris is usually considered like the spoil sports people, because everybody wants to do the cool missions and actually go places and provide technologies, services, or explore space. But the problem of debris is real. Everywhere where humans have been going in space, we have been leaving behind space debris. So in order to tackle the problem, one of the frontiers is mitigations to begin with. We are working that you think about in your mission planning already, what's the end of life, where's the debris going, and how to tackle that problem. So because the fewer debris pieces we are creating, the better the problem in the end.